So here we are. So last session we started with, of course, with the slices. We also discussed about the uh, appending a slice and then how the behavior of the slice whenever it gets appended. Uh, you know, how do we fill the slice and then return the slice? Why should we return the slice? Kind of a thing we discussed about. So just to recap and then give you a little bit of information once again. First thing, slice doesn't have a fixed length. Slice slice can grow. So slices can grow, or slices can shrink as well. Shrink means that actually slices can shrink. Shrink the slice, but yeah, you cannot shrink. Slices can grow, but you can arrange a slice in such a way that you can you can split the single slice into multiple slices and can shrink as well. I will show you later on. And slices slices behavior is basically based on the capacity of the slice. There is a header to the slice. That header, we already printed that header and then observed how the header behaves in the slice. It's all about the capacity of the slice is very, very important, and there is a function. That particular function is going to append the slice. That particular function, we call it as append. You can check whether slice is nil or not. Okay, a slice is null or not, we can check by checking nil. These kind of things we discussed. uh, we also printed this print line, print slice header function. We can go and then print the header of the slice. Okay, these things we already discussed, right? First thing, why did we fill the slice and return the slice? The reason is pretty simple. Whenever you are using some functions like append and all, it's always good to return the slice as well. Fine, let's go to the another behavior of the slice. The we also discussed about the string function, how string is different than slice. I always discuss about string and slice uh, together, because there is a reason for that, because string has got a header and slice also has got a header. The difference is string doesn't contain the capacity, but slice contains the capacity. Okay, let's go and then write another example. I'll take the session till 9 o'clock. Yeah, I've got some doctor appointment. So I got another example over here, code main.co. Fine. So what I do, I go and create a slice. Let's say slice 1 equal to integer of maybe 10, 20, 30, 40, 50. There are five elements in the slice. I create, so if you look at the header of the slice, the header is, there is a pointer, of course, there is a length which is 5, there is a capacity which is 5. So capacity algorithm of the slice is, whenever the slice length, you try to append a slice beyond its capacity, it's go and then doubles the capacity. Okay, let me check. Okay, I'll show you. how to how the capacity of the slice. We have a function which is going to print the let's say fmt.println, sorry, fmt.printf address of the slice, which got to be the actual address of the slice, and then fmt.println length of the slice, length of the slice, which is going to be length is a built-in function, and capacity of the slice, where again capacity is a built-in function. This is fine. And then the next thing what you got to do, you have to get the address of the actual address of the slice, fmt.println printf pointer of the slice. If you look at it, what exactly the pointer is the address of the zeroth element of the slice. That's going to be the starting pointer of the slice. So we got to print all these things, so this is the address of the slice, and this is the pointer of the slice. See this, the capacity is 5, length is 5. Now what I do is I append the slice. There is a built-in function called append. And this append function is how you can go and then increase the length of a slice. You have to use a function called append. By appending a slice, that the slice can grow. I append the slice with a number something like this. I think we saw already. Append is a built-in function. Append is going to append the slice. Then I print these three things. Let me print not only the address, print slice 1 is slice 1, print the slice itself. So the moment you append the slice, you see that this is the address of, this is the slice, this is the address of the slice. The moment you append, that means the header of the length gets changed. Append function, what happened? It's trying to increase the size of the slice. It goes to the append function. The moment you use append function, what happened is the capacity of the slice is doubled if it is crossing the length of the slice. It's very important about the slice. If you don't understand the header of the slice, you can't understand slices. The capacity of the slice is doubled. 5 would become 10. Okay. And then the moment the capacity is doubled, the address is also reassigned. That means when it goes beyond the capacity, the slice gets reassigned elsewhere. Okay, the slice would be reassigned, reallocated actually. It reallocates the memory of the slice. That's what actually the capacity of the slice. That's about the capacity of the slice. Okay, whenever the capacity of the slice goes uh, beyond the length, or whenever the length goes beyond the capacity, you're trying to append the slice, what happens? It's got beyond the capacity, then automatically it rearranges the slice. So right now the slice has a different memory, starting memory, than the earlier. So when I try to again append the slice, maybe I give 8888. Now the memory address is same, the starting memory address is same, unlike Here the memory address is different, 4000. Here a double triple zero, a triple zero, the address is different because it is within the capacity. The simple thing, capacity is always about how many elements that a slice currently can accommodate. The length itself, and length talks about how many elements are there in the slice, which it talks about the length. So there is a difference between, there is a relationship between length and capacity. That's what the length and capacity is. How many elements a slice can allocate is talks about the capacity. Overall, how many elements are already there, it talks about the length of the slice. Okay, there are these things are different. So length of the slice and then capacity of the slice. Okay. Okay. It's the length of the slice and the capacity of the slice. You see that. So the moment you use append function to the slice, whenever you use the append function to the slice, definitely the header gets changed. Header is not only about the capacity, header is also about the length. Here, what got changed inside the header of the slice? These three are the header of the slice. What got changed here? The length got changed. So whenever you try to append a slice, either the length gets changed or the three of them get changed. Three of them means a new memory is allocated to the slice, the capacity gets doubled and the length is increased to by one, or by one or two, by multiple. Actually, I tell you why it is multiple. Okay, again I try to append the slice by multiple elements. Also you can append the slice. Let's say 7777, 6666, 5555 and 4444. You see that the length is 7, the capacity is 10, but I'm trying to increment to 11. That's what I'm doing, the last instance. So this address is same. You see, you don't be confused. This is the address of the header. Header of address is always same. The header address is same. The header address is same. Now you see that this got changed. You see, CA00 is the starting point, but here CC00 is the starting point. That means the capacity is doubled. The length has become 7 to 11 because 4 elements we got to increase. Since it goes beyond the capacity got doubled. Now the capacity is 20. So since the capacity has to be increased, uh, it reallocates the slice. Okay, it reallocates the slice. Fine. I hope you understand what the capacity is, what the length and stuff like that. So what I do is I take this example, I write another example. Understanding slices are very important. If you understand slice, you understand many things in Go actually. Yeah. Now what I do is I create a slice from an underlining slice. So slice 2 is a slice that has created from slice 1. I have a variable called A which has got a value called 10. I have a variable called B which has got a variable called A. So A has a value called 1, B has a value called A. Okay, so A has a value called 1 and B has a value called A. Now tell me how many tens are there in memory? Other variable which you are assigning the value of A. There are two variables, two memories are allocated. So if you change B it would not affect A because A and B are not pointers. A and B are two different variables. If you change B, this is not going to affect A. If you really print line A, it's not going to affect A. You want to put B as well. It's not going to affect A. The reason is A and B are two different variables. A is still remain 10, B is 100. Fine. But what exactly is copied from A to B? What exactly copied from A to B is the data inside A. The data inside A is copied. Similarly, when I say slice 2 equal to slice 1, the data in the slice 1 is copied to slice 2. What is the data? What is slice 1? Slice 1 is a structure as which I'm talking about the header, which is header. Slice 2 also has a structure and the actual data is the header. So now what happened is the header of slice 2 and header of slice 1 are same. The header of slice 1 and header of slice 2 is, for example. What is the meaning of header? Header means not this is not the header. These three things are header. Length, capacity, and the actual pointer is the data inside the structure slice. The headers are same. Okay, that's what happened. The header of slice 2 is same as the header of uh, slice 1. Header means these three things. This is not a header. This is the address of slice 1 and the address of the slice 2. This is not the header. This is the address of slice 1 and then address of slice 2. Okay, header is different. Header means the value of the slice. Whenever I talk header, it's the value of the slice. Fine. So if I print it, slice 2 and print, so now I print slice 2 and then slice 1. What you notice is, so the header is same. You see that the header is same. This is what the actually value inside the structure, which we call it as a slice head. This is a different pointer. Both of them has its own pointer because two memories, but the headers are copied. So the pointer in slice 2, the zeroth index or zeroth pointer of slice 2 is same as the zeroth pointer of slice 1. Now what I do is I go and then change the slice 2's maybe first element with some value. Okay, so slice 1 and slice 2 are same values. What does it mean? The same values means they are all redirecting to the same header. So I'm going to change the value of slice 2 first element. That means this element to maybe some 9999. Now you see the value of slice 1 and you also see the values of slice 2. Both slice 1 and slice 2 got changed. The reason is slice 1 and slice 2 are Actually, the pointer inside the slices, which we call it the header, are heading to the same slice, same memory. I'm not again not talking about this memory. This is the address of slice one and address of the variable. I'm talking about the pointer inside the slice. If you really know the slice header, what does slice header contains? The slice header contains a pointer and length and capacity. This is what I'm talking about. The slice has got a pointer, that's a different thing. I'm talking about the slice header, not talking about the slice itself, slice pointer. Fine. Now what I do is I'll go and append slice 2 equal to append of some value. And then I go and change slice 2's zeroth element to maybe 1111. You see that what I did? I go and append slice 2 and then I change the value of slice 2's. Here I change the value of slice 1's first index. Here I'm going to do the zeroth index. So what happens to slice 1 and slice 2 is a question to you. So now both of them are divergent. We call it as the concept is called divergent. Both of them are diverging with respect to the headers. The reason is the moment you say the append slice 2, which is beyond the capacity of slice 2, it has to reallocate the memory. Then the header of slice 1 and the header of slice 2 are going in two different directions. Now whatever you do with slice 2 would not impact slice 1. Whatever you do with slice 2 would not impact slice 1. So whenever you are the rule of thumb here is if you are working with slices inside a function, if you are working with slices inside a function, always return the slice, particularly when you are using append function. The reason is append function is going to change your slice header, which would not reflect on the original slice. Change your slice header is not necessarily to be the length and capacity and the pointer, but also the length. So you should always copy it back. Simple thing. Here I append the slice. I append the slice and then I got the slice. I append the slice too. Now what I need to do, I need to assign back slice 2 to slice 1. So what happened? Headers are copied again. So once the headers are copied, slice 1 and slice 2 are again to the same memory. So if I make change in slice 2, that applies on slice 1 as well because the headers are copied. So generally what we do, this kind of things, if you're writing a function, let me go to the other example. So I create a function, for example, let me go and create a function. Let's say double and add and double. For example, a function is okay, double the slice, double the slice, you put a slice, double the slice. For index comma value, range of slice, slice of I equal to v into v. You're doubling the slice. Assume that simple function double the slice. I go and then double the slice of slice 1. Is it going to impact slice 1? So again I print the slice. See that it has doubled this slice. Even it has doubled the slice. Because slice 1 is passed here, so the header of slice 1 copied to this function because it's a pass by value, basically pass or call by value. What is the value of slice 1? The header is the value. The value is copied to this slice. It gets doubled internally, but the same value is copied, so it impacts the same slice. That means these three are same. So the same slice is going to be doubled. What if I create a function? Okay, write it back, double the slice. Let me, instead of double the slice, 2 times of the slice. Okay, double the slice, fine. Uh, what I can do here is bring down the slice, divide the slice. No, what I would, okay, I have to add the slice. I'm sorry for that. Add and double the slice. So I add an element to the slice. I add and double the slice. So what I do, I got to add the slice. Now I double the slice. So what I did, the first function, the first function, I square double the, not the double actually, I square the slice. Sorry for that. I square the slice. The original slice got squared. And then, okay, let me bring back the slice to the square root of the slice. After square again, you square root of the slice. So you take a value of the slice. So there is a math dot square root function. Square root function. You pass the float 64. So v is a integer of v, and you're going to get what? You're going to get float 64. So I have to convert it back to the integer. Sorry, float 64 of v. Now you are square root this slice. So what I did, I just square the slice. After that, I call a function square root of the slice, and then I print the slice. So what exactly I'm doing is I'm taking the slice, square root the slice, square the slice, and get back the original elements by calling the square root of the slice. Take the slice, square the slice, and square root the slice. No, because to otherwise it would keep on squaring the slice, it would go, we cannot understand. Now, what I do is add and square the slice. I'm adding a new element to the slice, and then square the elements of the slice. So here add and square the slice of slice 1 comma maybe a number called, what all numbers I give, 50, 60. Take the slice, assign the values, printing all the details of the slice, square the slice, printing the details, again bring back to the slice to the normal values, printing the slice, and add and square the slice. That means we are adding a new element to the slice before going to square. That's what we are doing. The original slice here, you take the slice, you double the slice and bring back the slice to the normal thing. But again you add and double the slice. There is no change on this slice one. Why is it? You need to understand about the slice. So what is the solution we can do to solve the problem is, number one, whenever you append the slice inside a function, whenever you see that the slice gets appended inside a function, always return the slice. So what exactly you are doing? You are returning the copied slice. Even the append function itself returns the slice. You see this. Append is a built-in function. You always return the slice. Thank you for that. Yeah, you return the slice. What happens when the slice gets returned? The headers are copied back. So whatever happens inside the slice, exactly, it's also the call by reference, whatever we're talking about. Whatever happens inside, they are copied back. They are copied back. The headers, in fact, I'm talking about the headers, are copied back to the original slice. So the headers are copied means, yeah, it is equipped with the data. If you again run it, so carefully observe the last two things, this one and this one at least. Here the capacity changed, the length got changed, it got its own address. Inside the slice, it it appends the slice because we said append function, and then you copied the slice back. Okay, so the slice is returned back. If the slice has more capacity, so slice is very, uh, it is very suspicious. It's not a suspicious way, it's the intended way of execution is like that. It works differently if you don't properly understand it. You feel like it is working very differently if you don't understand the uh, internal concepts of the slice. If you don't understand the internal concept of the slice, definitely we feel like why slice is behaving like that.
Can you show that output once more? Like header value is changing or not?
Header values changed. It got changed, the header value. The header value got changed. And then it is assigned back to the original slice. That's why. So internally, I'm not printing any header. So you see that the header value gets, this is the slice.
Mm.
This is where I'm appending. This is the address. And then this is a different address. Because the header got changed inside the function. Whatever the header got changed inside the function, we are copying it back to the original slice. We are okay. So what happened again? Original slice is along is has assigned with the original address. Okay, this is what the concept of slice with respect to append function. What if, for example, I don't want to return the slice. I don't want to return the slice. Let me write a function without returning the slice. Let me put it as R talks about return. Here I'm not going to return anything. Okay, so this is actually R, but I'm not going to return anything. What happens here is I'm going to create a slice and I append the slice. Okay, and then whenever I call function, add the slice 1 comma, I give it as 70. So if you really look at this again, the concept is little different now. The reason is, I tell you, you take the slice, you append the slice, so the capacity itself is 10. Since the capacity is 10, whatever happens on this, so it's not going to reallocate the memory, but there is a problem. The header got changed. Here the header is not changed with respect to the capacity and pointer, but with respect to the length. So it got changed, but the 7 into 7, 49,000 for 4,900 is not printed over here. The reason is the length is not changed. So header gets changed. So whatever you are doing, the append function, the rule of thumb is always return the slice. So here when you return the slice, the header is copied. The header is not only the address. The header is copied so that this is also printed. Header is not the address. Remember that header is even the length. Anything, any one of them gets changed here. Any one of them means either length or three of them. That is the case. If changes, it may change the length or it may change three of them. So these things would change. So whenever you perform append operation inside the slice, the rule is you have to follow one rule. You return the slice. Otherwise, we don't know, the header gets changed inside. Definitely header gets changed because it's an append operation. The header gets changed. And once the header is changed, it would not be reflected on the original slides. That's the most important thing. It would never ever reflected on the original slides. So this is the very the curious case of the slices. You have to be very careful about whenever you are working with slices. Slices are little different with respect to this. The reason is the behavior of the slice is purely depends on what kind of header it's going to return, how it is, and stuff like that. Right. That's what about the slices. So whenever you are performing operations on the slice, be careful that you know particularly the operations means I mean to say not any other operations. Whenever you are performing the append kind of operations on slice, always be aware that the header gets changed. So return the slice back. There is another way to do that. If you're using the pointers, there is other way to do that. But generally, okay, if you're performing the append operation on slice, you always return the slice. Return the slice back so that the header gets copied. Okay, these things you need to understand whenever you are working with slices. Okay, thank you very much. That's